Can you see the slide movement, students? Hello?
Yes, ma'am.
Okay, so today we'll take up one more lab program, right? So which is also based on the looping statement itself, right? Okay, so you already know about that. So I think you are able to answer for those things before we proceed with writing the program there, right? Okay, what the program is talking about. So let's look at the thing. Develop a C program to compute sin x, right? Okay, so you are supposed to find the value of the sine value of a given x value, right? Okay, you are given with the degree, and you are supposed to find the sine value of that particular, the what we call it as the angle, right? Angle that is measured are given in terms of degrees there. So for that you are supposed to use what? Okay, you are supposed to use the Taylor series. And we are not saying whatever value we are going to get, it is the accurate value. It's an approximation value that we people are finding for the sine of x there. Compare your result with the built-in library function. Okay, so you are supposed to apply a right algorithm. So using that talks about the Taylor series there, and whatever result you got out of the program that you have written using the Taylor series, so that result must be compared with built-in function. Built-in function is already available in C language. Okay, so what is a built-in function that is available in C for sine? What is a built-in function that is available to find the value of, a sine value of given x? Any one of you, please?
Math.h.
Pardon?
Math.h.
Math.h is the header file that we are supposed to add. Okay, what is the function that you are supposed to? If I am interested to find the square root of a number, okay, so what is a function that is available in C language?
SQRT.
Correct, no? So similar to that, what is the function, built-in function that is available to find the sine of a given x value?
Sine.
Pardon?
Sine to the bracket x.
Find itself.
Sine of x. Is it okay?
Yes, ma'am.
Yes.
Alright, so this is a function, built-in function that is available. So first you are supposed to find your result using a Taylor series, right? And whatever result you are going to get, so that has to be compared with the calculation that is done by the built-in function that is sin x. Okay, so you have to apply both the things. One built-in function, one you have to write a Taylor series to find the sin x there. And these two results will be compared, right? Okay, so now comparing means you have to display both the results, and you have to check it out whether whatever result you have calculated is almost equal, because you are going out with the approximation there. It should be very much closer to the value that we got after doing with the help of sin x built-in function there. Right? This is what the program is talking about, or the problem is talking about. Okay, are you clear with the problem statement? Develop a C program to find or to compute the sin x. So x should be in, what we call it as the, we will be reading the value of x in terms of degree. Okay, or this particular angle in terms of degree. But whenever it is given as an input for the sin x, is it in terms of degrees that you are supposed to provide?
No, ma'am.
No. What you're supposed to do?
Convert into radians.
Very good. Okay, so you have to give it in terms of radians, right? How do you convert the given value in terms of degree to radians there?
Multiplying by pi by 180.
Is that
Pi by
okay?
180.
Right? Pi by 180. But I don't know pi value. What is pi value? So again I have
3.142.
to, okay, so I have to declare this as a constant 3.142 and I have to multiply this by pi. Okay, either you directly multiply it by 3.142 or you take it as a constant and you multiply that constant with the given degree value and divide it by 180 degree. Okay, to get the x value in terms of radians. Is that clear to everybody? We people are always playing with the radians value whenever we go ahead with finding its values there. Maybe the sine value, maybe the cosine value, or any kind of values in term. If we are dealing with the angles there, angles must be defined in terms of radians. I hope you already know. So I'm just saying that because I need radians ray values before I proceed with them. So any doubt in this, students? So you have to understand the problem statement clearly, then only people can write the algorithm or the program for it. You have to compute the sin x. For that, you are supposed to use this Taylor series there. So we'll be mentioning what is that Taylor series there. Then compare your result. Whatever result you are going to get out of this, that should be compared with the value that you got out of the built-in function there. Okay, so both the results. If I say one result R1 that I got with the help of the Taylor series, R2 result that I got with the help of what we call it as. So whatever result I got with the help of what we call it as a built-in function there, built-in library function there. We are just comparing. So we want the results to be almost equal to each other. Print both the results. Okay, that's what they are saying. Print both the results and and appropriate message. You mention the messages along with the data value. So any doubt in the problem statement? Is problem statement is clear to everybody? Okay, so let's go ahead with the so Taylor series. What Taylor series is talking about? Okay, so if you look at Taylor series, how do you write the Taylor series there? How do you write Taylor series? Is this Taylor series? Is this the Taylor series?
Yes, ma'am.
Yes. Okay. So this what you people are providing there. So if I write a degree in terms of or the angle in terms of degrees, if I give something like 50 degree or 45 degree, something like that. So this has to be converted into radians before I proceed with. So you already know. So it has to be multiplied by pi and divided by 180 there. Whatever value I am having for d there, and whatever value I am going to get, I call it as x there. Okay, so this x I'll be taking. Then what I'm going to do next term, if I say this is a first term in the sin x of the Taylor series is, then next term is minus x cube divided by 3 factorial. Next term is plus x raised to 5 divided by 5 factorial. Next term is minus x raised to 7 divided by 7 factorial, and so on here. Right, so this is a Taylor series. You go on expanding this, right? Okay, so x value, you already know this is x value. And you can take the same x value and take the cube of that and divide it by the 3 factorial. For this, we are supposed to write the program, right? For this, which is going to do this calculation. For this, you are supposed to write the algorithm or program there, right? Okay, so now I say this is the first term, this is the second term, this is the third term, fourth term, and so on. Okay, my question is how many terms we need to take whenever we are interested to find the value of sin x or maybe cosine x there. How many terms we need to take?
X.
How many terms?
X
So I
term.
said x term means, so this is the first term, this is second term, third term, fourth term, and so on. These are the infinite terms. Right? But how many terms you are going to take?
N number of terms.
N, what is that n? I have to define it, I have to tell. because system won't know what is that n value. How many terms do you take?
Term equals n or x.
What is that? That's what I'm asking. Term is equal to, you are saying it is, okay, n. What is that n you are considering there? How many terms? Can I take only 2 terms? Can I take 3 terms? Okay, can I take 4 terms, 5 terms? How many terms usually you take for finding this sin x? That is my question now.
We can ask the user, ma'am.
Ask the user in the sense I didn't understand what to ask.
Provide-
Some
provide-
some students will say so take only 4 terms. Some students will take up to 20 terms. You take, I mean 25 terms. They'll say some students will take. Okay, so you take 60 terms, 70 terms, something like that. So what is okay? What is your idea? What you wanted to I mean say regarding that? Whether you want to restrict yourself to something like 15 terms or 20 terms, something like that. How many terms you are going to add there? 2 terms, 3 terms, 4 terms, 5 terms, 10 terms, 20 terms. How many terms you are interested to add?
How about initially taking it 1?
Initially taking it 1 in the sense, so I'll be getting whatever value, whatever radian value that you got, no, that itself is a sin x value there. Once you have, let me take, okay, 45. So what is the radian value of this? This is 45 degree. What is the radians of this value? Multiply this by 3.142 divided. Okay, so 180. So what is this value? I'm asking you, what is this value? Make it fast. Why are you slow? You have calculated. Pardon?
5 by
5 by? You
4.
multiply this. You tell me what is the value. 45 you multiplied by 3.142 divided by 180. What is the value that you got?
0.785.
0.785. Is it okay? What is the sine
Yes.
of 45? What is sine of 45? You have studied, no? Sine of 45. What is
1
sine
by
of 45? 1 by root 2. What is 1 by root 2 value?
Point 8509.
Check it out. Clearly check it out. Okay, 1 by root 2. Is it 1 by root 2? Sine of 45 is 1 by root 2?
No, ma'am. Yeah, answer is 0.707.
Yes,
70?
ma'am. 0.85. 7092.
7092. Correct, no?
Yeah, ma'am.
Is it okay? If I take only one term, you look at this. This is the answer that I got with the help of sin x. You said, okay, that is Taylor series. You told me to take only one term. I took only one term. I got the result as 0.785, and this calculation I got using a sine function there. Okay, this is I'll be using the library function sine of whatever x you have written there. So if I give, so I'm going to get this as 0.70. Okay, maybe 92 or 072, something like that. Okay, just check it out. Okay, so now I'm getting this. Do you feel is these two values are equal to each other, almost equal to each other?
Yes, ma'am.
Yes.
No. Now look at this. This is 0.08 here. This is point. Okay, because people are talking in terms of points only. So at least 3 to 4 terms should be equal to each other. Then only we say both are equal. If there are no equalness between at least 2 to 3 terms after decimal point, okay, then we cannot say both are equal. If you write it is 0.98 and if you write 0.90, if you say both are equal, then it is not acceptable. This is equivalent to 1 rupee, this is 90 paisa only. Okay, I hope that you know the difference between 1 rupee and 90 paisa. 10 paisa difference is there. Correct, no?
Yes, ma'am.
Right? So that's what you have to take care. So that also matters in case of these things. That's what I'm asking you. How many terms you are supposed to take? So that matters. So how many more terms you take, so that much accurate value you are going to get. So if you take lesser number of terms, you are moving away from the accuracy. I hope I'm making it clear to everybody. Okay, we have a habit of taking more number of terms. More number of terms means we are adding what we call it as, or we are moving what we call it as towards the accuracy. Clear, students?
Yes, ma'am.
Okay, any doubt, please don't hesitate to ask the question. What I asked you, have you understood? And what I explained you, have you understood that? I'm just asking you how many terms you are supposed to take, and you said me to take only one term. Then I told you I got some value for it, and I checked with the sin x value that is given by the actual the built-in function there, and I got this as you already know this value. Okay, 7.707 or 9, something like that, and whatever value you got, okay, there is a lot of difference, right? Okay, so now this shows me that taking one term is not helping me to find the accurate value. Then what should I do? What should I do?
Take more terms.
More terms, right? So how many terms then? More terms means how many terms?
So we can ask the user to input the n value, ma'am.
So that's why I'm asking you. Okay, so now it's very hard for anybody to tell you take only 5 terms, 6 terms, something like that. So what we people can decide how many terms you want to have equal after a decimal point. If I take decimal point here, right? Okay, so now I'll take 1, 2, 3, 4 terms, right? Say 4 terms of the result that I got out of the Taylor series is equivalent to whatever value that I got for the sin x are, equal that much. 4 terms are equal. If fifth term is varying there, so there is no issue. At least 4 to 5 terms, okay, are equal, then I am going to accept that. Then how do I check whether 4 terms are equal or no? So that's what I am suggesting here. Whenever you calculate the term, you check the term value. If the term value is becoming, because whenever you go ahead with the picking the new terms there, so it always moves towards a 0 value. People can check it out because this value is increasing there. So if it is increasing, it is moving towards a 0th value. So you'll be getting something like 0.0001, something like this. Right, so people can check it out. You go on dividing this particular number by this 3 factorial, then 5 factorial, then 6, 7 factorial, then 9 factorial. So whatever value you are going to get for the terms is going to decrease there. So here, how much accurate value you are interested in? Whether you want 4 digits to be equal, 5 digits to be equal there. So depending on that, so you select it till that term. So you are finding the value of the term there. If the term value, okay, whatever term value I'm picking there, if that is more than whatever digits that I wanted to compare there. Okay, if it is more than this particular value, then I'll tell you to add one more term. Once this particular term becomes okay lesser than this value, I'm coming out of the loop there. This is what is usually we people do. I hope I'm making it clear. I need your response, students. I need your response, students. Hello?
Yes, ma'am. Clear, ma'am.
Hello? Okay, so what did you understand from this? How many terms I have to take?
4 terms or 5 terms.
If I take the first, no, it's 4 terms, 5 terms never works. Okay, so 4 terms, 5 terms, you'll end up with only 7.65, something like that. I want, okay, if I take here, so can you give me the accurate value of sin of 45 exactly? Up to 5 digits. Any one of you?
0.70.
0.70710.
I'll write 1 second. 7.70.
71.
71.
7106.
What is that value? Sir,
71.
pardon?
Seven
71.
0.707106.
Okay, so now it's okay with me. So, okay, at least 4 digits. I want to have an accuracy. If I take only the first term, you said you know that you are going to get this as 78. What is the value you are going to get? Say if it is 45 degree, 45 you multiplied by 3.142 divided by, and if I take it as 180, so you got something like 78. How much?
78.7855.
55, right? Okay, so if you look at this first only, first digit is equal, but if you look at the other 3 terms, right, so they are not equal. I want other 3 terms to be equal also. That's why I go ahead with considering the next term there. Again, I'll just find out this value and I'll just check it out whether this value is, because if you calculate this value, it is always already meant to always move towards the 0.00, that is 0 value. All right. Okay, people can check it out. There is no issue. So x cube divided by, you find it out 3 factorial there. And you are going to subtract this particular value from this value. That's what Taylor series is talking about. First it is addition, then subtraction, then again plus. That is addition, again subtraction, and so on. You have to calculate this term. If this term is becoming equal to 0, right? So it is not becoming 0 there. So, but it is, you can take up to 4 terms, it is going to be 0 there. So after 5th term, it is having certain values there. So at least till 4th term, if it is 0, then I am going to stop there. Right? So I'm not deciding that, it is decided by the system itself. I'll be just checking. What I'm going to check, I'll calculate the term. Okay, it may be x cube or x raised to 5 divided by 7 factorial, or it may be x raised to 7 divided by, it is 7 divided by 7 factorial. This is 9 divided by 9 factorial. So I go on calculating these values. Okay, these are the terms. First, I'll check it out. Is it equal to this value or what? If it is not equal to this value, still it is this value is more than this value. Again, I'll go ahead with the calculating the next term there. If this term has becoming equal to 0 there, then I am going to stop there. This is what is the meaning of picking up the terms there and giving the accurate results there. Is it okay, students? This is what we are going to do in this case. How many terms? I am not defining. I am just finding what is the value of the term there. Depending on a term value there, whether that particular term will be added or not, I'll be deciding that. Is it okay? Is that okay, students?
Yes, ma'am.
Okay, so let's proceed with the same thing now. So this is usually actually this kind of stuff is already available in the header file there. You can directly use this. Okay, no need to define this also. You can directly m_pi. This is the pi value that is already existing in the math.h. Okay, in some of the programs, if you look at the textbook there, they directly use m_pi, but they are not defining it as using either hash define or as a constant there. Right? Why they are not defining that? Because it is already available in the math.h there. Okay, it is already available in the math.h there. Is it okay, students? Is it okay, students? You need not define that. It is already existing in the math.h there. You can directly use that. Clear, students?
Yes, ma'am.
Okay, so let's go ahead with the algorithm. So how do I begin with what I'm supposed to read for this? What you're supposed to read for this? X value. Are you reading X value?
Yes. X
Are you
values in
reading
degree.
X? Okay, so you are reading angles in degree. Correct? You are supposed to read the angle in degrees. Then I'll be converting this into radians. Okay, so that may be dumped inside the X. Right? So then I'll be using a Taylor series to find the value of this particular X value. Right? Okay, let's proceed with the same thing. So I'm going to read the angle in the right degrees. Okay, so start, read the angle in the degrees as degree now, right? So we are going to read a degree now. So now I'll be taking initially sine value is equal to a 0 there. Okay. Then you already know the terms. I hope you already know the terms. What is sine x? Sine of x is equal to, that is sine x function. How do you find sine x function? That is sine function only. I'll write only sine because you don't have any confusion just with the built-in function there. Sine is a variable. S-I-N-E I have written. How do you write the term? What is Taylor series is talking about? Tell me the Taylor series. Hello? Hello? Tell me the Taylor series, student.
Sin x equals to x plus
Okay, I'll write that for you all. Okay, so x minus
X cube.
so x cube by 3 factorial plus x raised to 5 divided by 5 factorial minus x raised to 7 divided by 7 factorial and so on. Correct now?
Yes, ma'am.
Right, so this is x
Yes.
means x raised to 1 divided by 1 factorial. Can I write like this? Is it okay?
Yes, ma'am.
Right. Now first I'll assign this to, okay, 1 point, this is my first term. Okay, then I'll be calculating the second term. Whenever I'm going ahead with the second term, okay, this should be assigned with a minus sign there. So that I have to take care. Right? So here I am having x. So next time I have to go ahead with the x raised to cube. Here I am having 1 factorial. Then, so next time I have to have 3 factorial. How do I get 3 factorial? So 3 factorial can be written as 2 into 1 factorial. Is it okay? Sorry, 3 into 2 into 1 factorial. Is it okay? If I
Yes,
write
ma'am.
5 factorial there, okay, so now 5 factorial, I have already 3 factorial with me, right? So then how do I write that? 5 into 4 into 3 factorial I can write,
Yes, ma'am.
right? So if I am going ahead with 7 factorial, I can write that into 7 into 6 into 5 there. Is it okay? Can I write like this? Is it okay? Right? Why I am writing like this? Because I have these terms that is already existing there. Okay, so if you look at this, so if for 3 factorial, I am using the 1 factorial that is already available. For 5 factorial, I am using the 3 factorial that is already available. So I am just multiplying 3 into 2 there. Then I am multiplying just 4 into 5 there, and I am using the previously generated 3 factorial here. Okay, if you go ahead with 7 factorial, I have already 5 factorial here. I'll be multiplying 7 into 6, then I'll be making use of this 5 factorial there. Is it okay? Because these are already existing in the previous terms. Agreed?
Yes, ma'am.
Okay, so what about the upper term then? First you have x raised to 1, then you have x cube there, then you have x raised to 5. How do you write these things then? So this x raised to 1 term is already existing, right? So I'll be making use of this term and then I'll be multiplying this with x square. Then I go ahead with this. I have already x raised to 3 is existing. I am just multiplying it by x square term. Is it agreeable?
Yes, ma'am.
Right? So if I am writing, if I am going ahead with x raised to 7, how can I write that? I'm already having x raised to 5 term in the previous value or previous term then. So x raised to 5 multiplied by x raised to 2 there. Is it okay? So everywhere x square is becoming common there. This is how we have to find the tricks. Is it okay?
Yes, ma'am.
Okay, so with this, so let's try to write the stuff now. Okay, so now first I'll convert this into radians before I proceed with, right? Okay, go ahead with finding the value of degrees into radians or convert the degree value into radians. How do you convert? You already know. You multiplied that by, okay, so now, multiply that by pi and divide it by 180 to convert that into radians. Is it okay? So I hope you already know this. There is no point in explaining this. Clear? So I got x value. Okay, what is this x term? X is the same value that you have read, but it in terms of radians here. Is it okay? Say something.
Yes, ma'am.
Okay, so let's proceed with the algorithm. Now we are going to write the Taylor series. Little concentration is required. Okay, so just look into the things now. Right, so we are proceeding with the sum of the terms now. Right, sine series calculation. First, what is my numerator? Numerator is x, because the first term of this is x and divided by 1 factorial. So this is my numerator and denominator is 1. So I'll say the same thing, denominator is equal to 1. Is it okay? Is this okay?
Yes, ma'am.
Okay. Then, so what do I do now? So I'll take, I'm interested to, this is my first term. Okay, I'll proceed with the next value. Right, so the next value you already know, this is 1, but I want this to be 3 factorial next time. I don't want it to be 2 factorial here. Correct? No, because sine series is telling like that. Sine series is telling me that it should be 3 cube divided, x cube divided by 3 factorial. These are the odd numbers that I am supposed to generate. Agreed?
Yes, ma'am.
Agreed, students? Okay. Then how do I do this? Okay, so now you know that whenever you start, if I take any value there, if it is 1, how do I get the next odd number there or even number there? If this is first number, how do I
Yes,
get the
ma'am.
next? Plus 2, no?
Yes,
Yes,
Yes
ma'am.
or no? Right, so plus 2 I have to do. Here also I am initializing it to plus 2 so that I can generate the even numbers or the odd numbers there. Right, so in this case I am generating odd numbers there. So it is helping me to do that. So I am initializing that I to 2 there. How exactly it is helping me, I will be showing in the next. So is it okay to everybody? I am not counting any terms because I know that I'll first find out the term value. If the term value is greater than particular value, how many digits I already mentioned. If it is greater than this value, then you add up to the sign term there. Otherwise, you just eliminate or come out of the loop there. That's what you're supposed to do. Right? So go ahead with the
yes, ma'am.
do loop now. Okay, so now I'll go ahead with do. What I'm going to do, I'm going to find the term value. What is term? The first term. Numerator divided by denominator. I'm doing the same thing. Term is equal to numerator divided by denominator. So I got this as x by 1. Is it okay? Is it okay? This is the first term.
Yes,
Okay?
ma'am.
Okay. Then I am going to get the, okay, so next term. Okay, so if you want to find sine here, then afterwards you want to generate the next term, that is also possible. You can write sine is equal to, I have already initialized that sine term here, 0. It is initialized to 0 here. Okay, so you can use that and you can write that as sine is equal to sine plus term. Okay, so this is initially 0. I am adding term to this. The term value is initially x here. Right, so now this is the first term that is added to sine now. Is it okay? Sine series is equal to x minus x cube divided by 3 factorial plus x raised to 5 divided by 5 factorial plus minus x raised to 7 divided by 7 factorial. Is it okay? Is this okay? Till here, is it okay?
Yes,
Now
ma'am.
you can write this afterwards or you can write it at the end also. There is no issue. Right? Okay. Then how do I get the next numerator? Next numerator now? Next numerator I am expecting it to be x cube divided by 3 factorial. How do I get this? How do I get x
Multiply
cube?
with x value.
Okay, because I said that the next term is minus. So this is minus here. I am taking it as minus here. The first term. So first term as it is I am taking. Right, this is the first value, no? Numerator of that is x. Is it okay? Right, so now I am multiplying it with x square. That's what I was saying in the last slide. Last explanation. So you are supposed to write x into x square. Then you have x cube already. Then you have to multiply this with x square. Then I have already x raised to 5. Then you have to multiply this with x square. So this gives me x raised to, first initially I have x, then x cube, x raised to 5, x raised to 7, and so on. So this term is constant here. That's what we are keeping it constant. Is it okay? So this is only the numerator that is changing. So initially it is x, taken the same thing, I am multiplying this with x square. So I am going to get this as x cube with minus sign. Is it okay?
Yes, ma'am.
Is this okay? Right. So divided by what? Divided by 3 factorial. How do I write 3 factorial? You know that 3 factorial can be written as 3 into 2 into 1 factorial. Correct? No. Yes or no? Okay. So this 3 and how do I write? So I know that I value is 2 there, right? And how do I write? So I'll be writing denominator is 1 there. This is nothing but my denominator. Here it is 1. So if I go ahead with 5 factorial, so I can write this as 5 into 4 into 3 factorial. Okay. So this is a denominator. If you look at here, it is a denominator. So next time, so I'll take care of only multiplying with 5 into 4. This particular stuff, I'll be adding 1 to this to get the next number. That's what I'm doing. So this is later. This is 1 I got here. This is what I have written here.
Ma'am, your voice is not clear.
So this is the denominator. Multiplication 3. So hello, am I audible now? Hello? Hello? Hello students, am I audible now? Okay.
Yes, ma'am.
Okay. So next, yeah. So this is 1. So this is now 2 into this is 3. So this is 1. Is it 3 factorial now? Is it 3
Yes,
factorial?
ma'am.
Okay, what about the now? What about the upper part? What is this value?
X cube, ma'am.
What is numerator value? So this is x into x into x. So this is x cube. What is denominator? Denominator is 1 into 3 into 1 into 2, 3 there. So this is 3 factorial. So have you got the next term of the Taylor series here?
Yes, ma'am.
Have you got the next term of this, Taylor series here? Agreed? Yes or no?
Yes, ma'am.
Okay. Then I said you can write the sign function there. So this sign can be written before this also, or here also, because I'm not doing calculation of the term here. I'm just finding the next term in the form of denominator and a numerator there. So afterwards, I'll be making it as a term, right? So once I come back here, that time I'm making it as a term. So till that time, whatever previous value people are having, that is x by 1. Is x raised to 1 divided by 1 factorial is the term there. So sign is initialized to 0. So I'll be getting the value inside this sign as x raised to 1 divided by 1 factorial. It is the first term there. And I said I'll be repeating this till, okay, so before that, I have to add with next value. It to be 5 factorial. To get it as 5 factorial, so what is the next thing that I'm supposed to take here? I have already 3 factorial with me inside the denominator. But how can I make a 3 factorial into 5 factorial? Make it fast.
Multiplying
How can I
5 and
make
4.
I that you people are presently having?
4.
Ma'am, my voice is not clear.
Is it 4? Here it is 2. So others saying that it is good to them. Am I audible, students?
Ma'am,
Hello?
your voice is breaking, ma'am.
So, what other students? Am I audible, students?
Ma'am,
Ma'am, it's not
voice is
clear.
breaking.
Hello? Am I audible now? Hello?
Yes, ma'am.
Ma'am, you're audible,
Hello?
but it's not
Am I
clear. Your voice is not
audible
clear.
now? Because of a problem, I really don't know. Okay, because that how I used to teach daily, I'll be teaching in the similar fashion. Is it okay? Hello?
Yes, ma'am.
Hello? Okay, is it audible now? Hello, is it audible now?
Yes, ma'am.
Okay. So look at this now. So what is the value of I now? What is initially? What is the value of I?
2. 2, ma'am.
2.
Hello? 2. Right? Okay. So next I wanted to make this as 4 into, right? So I'll be just adding 1 to it to make it as the next number, to generate the next number. So I want to get the next even number there. How do I make this as next? How do I get the next even number there?
Add 2, ma'am.
Add 2 to this, correct? Whatever values of I is there, you add the 2 to this to get the next even number. That's what we people are doing in the next step there. Is it okay? So this is
Yes, ma'am.
now. So how many times this loop has to be repeated there? That's what I am writing in the while loop there. So whatever term, that is sign value that whatever term value that I got calculated there, so that term value should be more. So how many digits you want? That is accuracy you want. 1, 2, 3, 4 digits.
Ma'am, your voice is breaking.
Okay, so the digits after decimal point. That much accuracy we are interested in. So if this data.
Ma'am, voice is breaking, ma'am. Not clear.
Okay, so now can you able? Am I audible? I am using the mic also. Right, so now if it's not audible means.
Ma'am, your voice is lagging and also cracking up.
So maybe because of the problem. Okay. And am I audible now? Hello? 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 Hello, am I audible? Students? Hello? Hello? Hello?
Yes, ma'am.
Hello,
It's
students?
audible. Yes, ma'am. Now you're audible.
Audible. Okay, fine. Okay. So now look at the stuff now, right? So now I'm looking for the minimum of 4 digits to be equivalent to the, okay, the value that is accuracy, that I wanted to reach there, right? So now if whatever value I'm going to calculate, if that term is equating towards 0 there, so then that time I'm going to stop there. So how much accuracy? So I said, so this term minimum 4 digit accuracy I'm interested in. It is left to you people whether you want only 2 terms to be, I mean 2 digits to be 2 digits accuracy, 3 digit accuracy, 4 digit accuracy after decimal point. It is left to you people. So till that time, you people can take that value. So calculating that value, you are checking that value with the 0.001 there. And please remember, I am going ahead with fabs there because I want this term to be a plus value there. So that's why I'm making this as a plus value, because here you know that in some cases the this particular term value is going to become minus there, because sine x or sine is equal to x minus x cube divided by 3 factorial. Sometimes it is minus, sometimes it is plus there. Okay, but here I am comparing with only positive value, so that's why I have to take care of that particular term in terms of only positive value. Is it okay, students? Is that okay, students? Okay. Then
Yes.
once I come out of this, I have the accurate value, or I have got the sine value there. Okay, that is found inside whatever you have here, sine there, and you just print the same thing there. Print by calculation degree and the sine there. Okay, so now by calculation, whatever value you got for the sine, to which degree you have read there, and you do it the same thing using the library function also. Right, by library sin x function, and write it as, okay, so you have already know it's a degree that you have already read, and sin x, this is the library function that is already available inside the C language there. Is it okay? Is that okay, students? Is that okay, students? Hello? Hello? I need your response, students. Hello? Hello?
Yes, ma'am.
Okay, so go ahead with the program. Right, so now whatever algorithm we have written, we'll be just translating that into program now. So what I am supposed to do? Okay, I have to include which library files? Which header files?
Math.
Math.h. Okay. Then
Then
only
STO.
math.
standard
STDIO.
HTML.
stdio.h. Right? stdio.h and math.h, I'll be including that. Okay, so if you want to define it separately, you define it. Otherwise, you people can use math. Okay, that is m underscore pi directly inside your program there. It is left to you people. Okay, sometimes we may forget. That's why we have defined it. Pi 3.141539 there. Right? So now you define this. Then next, use the main. So you are supposed to declare the variables. Only these variables are we are going to use there. Floating point values are x, numerator, terms, denominator, and the sign is initialized to 0 there. Then enter the angle in degree that you are supposed to read there. I'm reading that. Okay, once I read that, so I'll try to convert that into radians. We are converting that, just multiplying it by pi and dividing it by 180.0 there. All right, so once I do that, so I have the data or the angle in radians now. Then I'll use the sign using the, I'll calculate the sign using the Taylor series there. Right, so this is initialization. Numerator is equal to x, denominator is equal to 1 there. This is the first term that you are writing there. And what about the I value there? What is the value of I? What is the value of I? 2. Okay.
2.
So I is equal to 2 there. Then go ahead with do there. So do, which are the terms that I am supposed to write here? First I have to calculate the term. Term is equal to what?
Numerator by denominator.
Very good. Numerator divided by denominator. Then what is sign value? Okay, first I mean, in this case also, I'm finding the next term. What is next numerator term? First numerator, first you already
Numerator
know.
into x.
So that is x
X
cube
cube.
divided by, right? So this is how do I get? You already know this is x here. So I've taken just minus for this because I want it to be minus there. Then it should be multiplied with x square. What about denominator? Is it okay?
Denominator.
Yes.
Denominator is equal to, denominator is 1 here. 1 is multiplied with, this is 2 and 3. So this is nothing but the 3 factorial there. Then I'm supposed to find the sign value there. So sign is equal to sign plus term there, right? So initially some sign is equal to 0 there. I'm adding the first term that I've calculated. First term that what I got is x here. Then just adding it to sign here, right? Okay, I'll be every time whenever I calculate, because I already told you first I need 1 factorial, then I need 3 factorial, then I need 5 factorial and so on, right? So I have initialized I value as 2, so that I can get the next even number there. First it is 2, then I need 4, because I am able to get the next value of this particular value there. Okay, so this gives me for this 5 factorial, this is giving me 3 factorial, this is 1 factorial there. This is how it is helping me, right? Okay, so I'll be continuing this till I get this particular term value that I got. Please remember, this has to be converted into absolute value before I proceed with checking this condition, right? Because sometimes I get a minus value, sometimes I get a positive value there, but I want the comparisons should be with the positive value itself. That's why I'm converting absolute this term to be an absolute value. Is it okay? Is it okay, students?
Yes, sir.
Right? Okay, so once I come out of this, so what I'm going to do by calculation, so I'll be writing it as sine of percentage d, right? So whatever angle that is you have given, maybe 45, then it is going to give us the 45 along with its value that you got here, right? So whatever value you have calculated here, so that value it is going to give us. Okay, whatever value you got here for the sine. Okay, so that value is going to be printed here. Then I have to do the same thing using the library function. By library function, I'll write sine of percentage d. This is my degree there. Maybe again, whatever value you're reading here. And with minus LF is, okay, what we call it as the sine of x. This is library function. Okay, you are using the math.h. Because of that, you are capable of using this. Is it okay? Then return 0, end of the main program. Is it okay, students?
Yes, ma'am.
Right? So if you look at the example of this, working of this, now look at the examples. I've given enter the angle in degrees, it's 45 degree. By calculation of that is sine of 45, it's using Taylor series. The first one is using the Taylor series. So you got result as this. So using library function, it is using the library function of the C language. So it is giving you. So are they almost equal to each other?
Yes, ma'am.
Right? Okay, so go ahead with the next one. So by calculation, sine of 90 is 1 here. Okay, so now sine of 90, that is, it is using the library function here, it is 1. So both are equal there. So I'm not saying both are exactly equal. Sometimes they may exactly equal, but it is always not true, because I have considered only 4 digits there. So up to 4 digit, so you can expect the good results there. Right, so sine of 0. Okay, so it's also 0 there. Right, so these are some of the examples that I have quoted for the sine. Okay, any doubt regarding this, students? Hello? 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 Do you have any doubts regarding this, students?
No, ma'am.
Oh, no? So this is, again I'm saying, so this is one of the lab program. This is the 9th lab program. Can you see the slides, no? Can you see the slide movement or no?
No, ma'am.
No.
No, ma'am.
Okay, now can you see now?
Yes, ma'am.
Yes, ma'am.
Okay, so now this is the 9th program. Okay, so now, so I mean, this is the lab program I'm talking about, 9th lab program. Right? Every program has got its own way. Okay, so please be prepared with every program there. So you have any doubts, you people can ask me. I will close session.